In this lecture, we trace the curve r equal to a times of 1 plus cos theta. Since it is polar curve, so while tracing this curve, we have to check the following points. The point number one is about symmetry. So how to check the symmetry about the polar curve? So we know that there are three types of symmetry about the pole, about the initial line theta equal to 0, and about the line theta equal to pi by 2. So first check what is the symmetry about the pole. Here, since if we replace r by minus r, the equation of the curve will change. So it is not symmetric about the pole. Let us check the symmetric about the initial line theta equal to 0. Since the equation to the curve remains unchanged by changing theta to minus theta, so the given curve is symmetric about the initial line theta equal to 0. Because if we replace theta by minus theta, so cos of minus theta is cos theta. Hence, the given curve remains unchanged while changing theta by minus theta. So the curve is symmetric about the initial line theta equal to 0. Now, if you want to check about the symmetry about the line theta equal to pi by 2, so if we replace r by minus r and theta by minus theta, r by minus r, so minus r, which is equal to a times of 1 plus 1 plus cos theta. Because cos of minus theta is cos theta. So this equation and this equation both are different. So we say that the curve is not symmetric about the line theta equal to pi by 2. Also, if we have already seen that there are two method to check the symmetric about line theta equal to pi by 2. So if we replace theta by pi minus theta, then also we know that cos pi minus theta is equal to minus cos theta. So again, if we replace only the theta by pi minus theta, so it will become r equal to a1 minus cos theta. So which is again the different equation, which is different from the given equation. Hence, the given curve is no symmetry about the line theta equal to 0. So it has only one symmetry, which is about the initial line theta equal to 0. Next point about the pole. What about the pole? The curve passes through pole or not? So for simply, if you want to check that the curve passes through pole or not, we have to just put r equal to 0 here. If you put r equal to 0, what we are getting? 0 equal to a times of 1 plus cos theta. And since a will not become 0, so 1 plus cos theta equal to 0, r cos theta equal to minus 1. And we know that the cos pi is minus 1, so theta equal to pi. What it means? It means that if you put theta equal to pi in the given equation, right? If you put cos theta, theta equal to pi means cos pi. So what is the value of r? R equal to a 1 plus cos pi is equal to, what is cos pi? Cos pi is minus 1. It will given a times of 1 minus 1, which is equal to 0. So since for the value of theta equal to pi, the value of r becomes 0, so we say that the curve passes through pole. Now the second point comes that if the curve passes through pole, what is the tangent at pole? So finding the tangent at pole, we have to just put r equal to 0, then we are able to get the value of theta. That is the tangent at pole. So we have already done this thing, a times of 1 plus cos theta equal to 0, which gives us 1 plus cos theta equal to 0, and cos theta equal to minus 1, which is cos pi, and hence theta equal to pi is the tangent at pole, right? Okay, let us go to the next point, which is angle between the radius vector and tangent. Means what is, we want to find out the tangent at any particular point of the polar curve. So that is given by tan phi is equal to r d theta dr. So differentiating one, which is r equal to a times of 1 plus cos theta, with respect to theta, we have dr d theta equal to derivative of 1 equal to 0 and derivative of cos theta is minus sine theta. It means dr d theta equal to minus a sine theta. And now if we interchange it, d theta dr, right? We have to reverse it because we have the relation r dr d theta. So d theta dr is equal to 1 upon minus a sine theta. And if you multiply by r on both the sides, r d theta dr, which is equal to r upon minus a sine theta. Again, the value of r is what? The value of r is a times of 1 plus cos theta. So this a will cancel. 1 plus cos theta is nothing but 2 cos square theta by 2, and sine theta is 2 cos theta by 2 sine theta by 2. There is again minus sign, so we will write down minus 2 cos theta by 2 sine theta by 2. This 2 will cancel, 1 cos will cancel. We have cos theta by 2 upon minus sine theta by 2, which can be written as minus cot theta by 2, or we can write down tan phi is equal to tan pi by 2 plus theta by 2, which gives us phi is equal to pi by 2 plus theta by 2. Thus, this is the relation between the radius vector and tangent. Let us try to find some table values for here. Now, we have given the curve r equal to a times of 1 plus cos theta. If you put theta equal to 0, cos 0 is 1, so r equal to 2a. And if we put theta equal to pi 0 over here, this is what is the value of phi? It is pi by 2. Next thing, uh, if we put theta equal to pi by 2, theta is pi by 2. So cos pi by 2 is 0. So r equal to only a. And here if you put theta equal to pi by 2, this means pi by 2 into 1 by 2 is pi by 4. So pi by 2 plus pi by 4 is nothing but 3 pi by 4. And now if you put the value of theta is equal to pi, then cos pi is minus 1. So minus 1 plus 1 is 0. So r equal to 0. And what about phi? Phi will be, this is pi. So pi by 2 plus pi by 2, which gives us pi. So these are three values we have considered. Okay, and then let us try to uh, do some notice some important points from this table. It is clear from the table that if theta increases from 0 to pi, theta increases from 0 to pi, then r decreases from 2a to 0. Just look here, value of theta is 0, its value is 2a, pi by 2 it is a, and if you put theta is pi, then its value is 0. So 2a to 0. Hence, the approximate shape of the given curve is as shown in the figure. How to trace this curve? So let me show the figure. The first thing, let me try to write down. This is the pole. Yeah. So first thing, the curve is symmetric about the initial line theta equal to. So this is initial line. Initial line. So the curve is symmetric about the initial line. So and now theta equal to pi. This is what? It is the tangent at pole. This theta equal to pi is tangent at pole. So we can draw, this is tangent. This is tangent means what? We can draw the one branch of the curve over here. And since it is symmetric about the initial line theta equal to 0, so we have the second part of the curve. Right. Like this. Now, second thing, if r equal to theta equal to 0, theta equal to 0 here, theta equal to 0, the value of r equal to 2a. This is the pole theta equal to 0. This is the another point theta equal to 2a. And at this point, tangent is what? What is the tangent? What is the tangent at this point? It is pi by 2, sorry. Yeah, it is pi by 2. So this theta equal to pi by 2 is the tangent, which tangent is perpendicular to the initial line theta equal to 0. This is tangent and this is also tangent, right? And another thing, let us take the another pi by 2. If what is the value of, if we put theta equal to pi by 2, what is the tangent? 3 pi by 4. 3 pi by 4 means what? At this point, what is the tangent? This is the tangent like that. No, like this. Okay, so, and if you put theta equal to pi, it is again, this is pi. So the value of this is 2a, right? And then at theta equal to pi by 2, this point, right? What is the tangent? It is 3 pi by 4. So this is tangent at this point, this is tangent at this point, right? And this is tangent at this point. So how we are able to do this? And now again, since this is pole 0, 0, and this is point 2a 0, and we know that if there is 2 point, then definitely there should be a closed loop between them. So now this is the, we are getting the first part of the curve. And since the curve is symmetric about the initial line, so we get the same type of curve also below the initial line. Hence, this is the approximate shape of the given curve. Thank you.